take a moment to model a few strategies for you that I really like to use when working on word problems and problem solving with students. So before we begin, the place that I got this word problem from is called Illustrative Mathematics or Illustrative Mathematics, and they have a lot of great math tasks for free. So if you go to that website and go to free resources and then go to content standards, you can look up math tasks that are really rigorous by standard. So that's a really great resource that you want to keep. Next, the two strategies that I'm going to use are called cover the numbers, and then we're just going to be connecting information in our word problem. So sorry this isn't the greatest view. I don't really have a whiteboard at home that I can use, so I use this window, but I hope that you can see the problem and kind of follow along with the problem solving strategies that I use. All right, so let's begin. So with the cover number strategy, you'll notice that I have some sticky notes on my problem, and I've actually covered up the numbers. And the reason I use this strategy is because when you're often introducing a new word problem to the class, kids want to start grabbing on numbers and operating with them right away, especially your kids who love math or the ones who are pretty quick at math. They could call out the correct answer in the middle of you just introducing the problem, and the rest of the class have been robbed of the opportunity to solve it. So by covering the numbers, nobody can solve the problem and they can just focus on the content. All right, so here's the problem. All right, so Alex is training for his school's jogathon, and he needs to run at least blank miles per day. All right, so we stop at the first sentence and we start talking to the students about the information that they learned. And so in the first sentence, we learned something about Alex and what is Alex doing? And so now I'm going to use my questioning to the students. So we know that Alex is training for a school's jogathon. Now, what are the requirements of that jogathon? What does he have to do? You might ask students to turn and talk, and they would come up with the information that he has a certain amount of miles he has to run. And what does this word per day mean? Per day means every day he has to run a certain amount of miles. We don't know how many miles yet, but we will find out when we're ready to solve the problem. So you'll have students restate, what do we learn, what do we know? We know that Alex is in a jogathon and that he has to run a certain amount of miles every day. And so then you might clarify for students, what does that look like? So that means if there's the number 5 under here, that means every single day, Alex has to run 5 miles. 5 miles Monday, 5 miles Tuesday, 5 miles Wednesday. And so that helps students kind of visualize what's happening in the problem before we move on to the next step. The next step, we're going to want to connect information to our first sentence. So watch how that's done. So now we know if he runs to his grandma's house, which is blank of a mile away, let's go ahead and stop here. So we know that he has to run a certain amount of miles every day. And then now we know if he runs to his grandma's house, it is a portion of a mile away. So we know it's if he says of a mile, so what would that mean, of a mile? It means we're taking a piece of a mile, a portion of a mile. How might we represent a portion of a whole? Good, fractions or decimals. So those are both different ways that we could represent it. So we know we could go to grandma's house, and that's going to be a part of a mile. Let's see if that will help us and see how it's connected to that first sentence. So now that we know he's going to the jogathon and he has to run a certain amount of miles a day, if he runs to grandma's house, that's going to help him do what? That's going to help him meet his goal for the jogathon. So he's got part of that goal. We don't know how far grandma's house is yet, and we don't know what his goal is for the jogathon. Let's keep reading. So after he runs to his grandma's house, then to his friend Justin's house, which is blank miles away. So again, we have him being able to run to another place. So we have grandma's and Justin's. So when we think about those two things, what is happening to these two numbers, going to Grandma's house and going to Justin's house? What do you think? What type of operation are we doing? Go ahead and turn and talk. You have students turn and talk about that. Okay, how is Grandma's house connected to Justin's house? Have them turn and talk. And how is this information important to our first sentence of him having to run a certain amount of miles in a day? So those are the types of questions we ask of students so they start to understand what's happening in the context. Let's keep going. So, will he have trained enough for the day? So what we're gonna do is, see, what is this question asking us? Will he have trained enough for the day? Go ahead and turn and talk about how this is connected to Grandma's house, Justin's house, and his goal for the day. What is this asking us? And so you'll ask questions like that, have kids turn and talk, that way everybody has an opportunity to think, and then you come back together as a class and discuss it. So we're trying to find out is how far he runs going to Grandma's and Justin's. Is that enough to meet his daily goal? Okay, so I want you to turn and talk about what would you do with these numbers? What would you have to do to determine if he trained enough for the day once we find out what is under our sticky notes? So at this point, students are discussing solution strategies. How would they solve this? The great thing with this strategy is no one can solve it yet, so they're stuck in this place where they have to talk about solution strategies. You'll find that kids want to start solving right here in this turn and talk if they have the numbers, and they'll tell the answers to their partners. But it's not time to start solving yet. Time to start solving is once I release you. So this is how it will go. All right, boys and girls, how did you, what did you talk about in your turn and talk? What does it mean, will he have trained enough for the day? And how is this related to the information that we learned about Alex? So students would be giving things like, well, if we put Justin's house and Grandma's house together, we'll have to see if it's enough for what his goal is. Then, luckily that fell off because it's time to reveal the numbers. After they've talked about it, you'll say, okay, so once you have the numbers, what are you going to do? How are you going to solve this? And so they might say, I'm going to draw a picture. I'm going to use, fraction tiles. I'm going to just add my fractions or whatever it may be. So let's go ahead, reveal the numbers. So he has to run 1 mile per day. That's his goal. His grandma is 5/8 of a mile away. And Justin is half a mile away. I want you all to go back to your seats, get out your math notebook, and start trying to solve this problem. And that's what it would look like before giving the answer, or when you're taking off the answers. You release students to go do their work. You walk around, ask questions, facilitate learning, talk about things like these are uncommon denominators and what do we need to do to be able to solve this problem. And then after students have had time to grapple with the problem, you come back together, share solution strategies. Students share their different ways of thinking. You chart those ways. For example, if students just changed the denominators and added their fractions, that would be one strategy. If students used fraction tiles, that would be another strategy. If they drew pictures, that would be another strategy. So as you're walking around, you're taking note of who's using different strategies, and you let them know, hey, Sarah, I'm gonna have you share your strategy at the end. And then you call them up, they share their thinking. The students are modeling, not the teacher. Now, students aren't the greatest at sharing their thinking, and so it's your job to help clarify and ask questions and chart it so the whole class understands as they get used to sharing their thinking. I hope this strategy is helpful.